So we have Darcy's law, which is saying that the flux is equal to the negative of the area through which water is flowing times the conductivity times the gradient in total potential. Now, we've then said, oh, we need to characterize this hydraulic conductivity as a function of the moisture content of the system, for example. And so we drew these graphs where we had on this axis hydraulic conductivity, which is going to be a function of the water content. And here we have the water content. And as we recall, at residual water content, the conductivity goes to 0. And then at theta sat, it goes to full saturated conductivity. And we end up with a curve connecting those two. And there we have our our conductivity curve, our hydraulic conductivity curve. Now the question is, what happens if I am not water? So for example, if I'm looking at the permeability to air. Well, let's think about it for a second. Remember what we had. We had the soil. And when we had the water at some sort of dry area, the water would tuck itself into little crevices. But what would it do? It would leave the big pores empty. So the big pores are staying empty. So what that means is that the air, if we want to put air through this system, for example, the air can go freely through the biggest pores, and the water is tucked away in these little pores. Who cares? So if we then, on the other axis, said, well, then let's draw the air permeability, say. We'll call it air permeability, and we'll call this the saturated air permeability. Now, our first temptation is to say, oh, well, we've done this, we know about all that, how things drop, but it's different. Because when we are at low water content, all those little blobs of water don't really matter. So unlike the hydraulic conductivity, which drops really rapidly, the air permeability stays rather high for a long time and only drops later. Okay? And so we see that the relative permeability to air in soil is very different than that of water. We will get to a point where the air can no longer percolate through the soil. And so we have what we might call the percolation threshold. And that's the place where the water films are now going to block up enough of this system so that even though there may be some air in here, it's now isolated, and that air it does not participate in transport. So we can have air pockets that do not allow any movement of air. And that's called the percolation threshold. Now, we've talked about air, but guess what? This also is applicable to any oil or other non-wetting fluid. So a non-wetting fluid, we mean that the water wets the soil. The oils will ride on top of the water and won't wet the particles. So air permeability and other non-wetting fluids like oils, gasoline, other contaminants will follow this permeability curve rather than the water. A wetting fluid follows that one. And that's how we think about the relative permeability of different fluids in soils.